Hello, welcome to Ascending DC channel. We are an AWS certified partner to provide cloud consulting and technical support to clients who are looking for cloud solutions to tackle the challenge in their day-to-day operations. This video is one of the many short videos we are producing. In each of them, we're going to demo and explain when used for AWS practice that can be used to improve the efficiency and accuracy of your work. All these tricks have been proved effective in our clients' success. If you are a project manager, DevOps, architect, software engineer, or just looking for useful cloud practice, this video is made for you. Please like, share, and subscribe to our channel. Thank you.
Hello, everyone. Today, we will talk about building and deploying a fraud detection models on AWS. Kelvin will go over the essential instruction and run a demo for us. Kelvin, you're up.
Okay. Hello, my name is Kelvin. I'm a data engineer in Ascending. In this video, we are going through the following topics. First, we will introduce what Amazon SageMaker is. Next, we will focus on our use case for leveraging the SageMaker and explain why SageMaker is the best fit for our technical requirements. Finally, we will demonstrate how we use the SageMaker notebook instance to implement a complete machine learning process from data preprocessing to model deployment and evaluation. In recent years, with the popularity of machine learning and due to some limitations of local equipment and long-term overhead, managed machine learning cloud services become more and more popular. Amazon SageMaker is one of them, which is a fully managed machine learning service provided and supported by AWS. With SageMaker, data scientists and developers can quickly and easily build and train machine learning models, and then directly deploy them into a production-ready hosted environment. SageMaker contains a lot of features. For example, it provides an integrated Jupyter authoring notebook instance for easy access to your data sources for exploration and analysis. So you don't have to manage servers. It also provides common machine learning algorithms optimized to run efficiently against extensive data in a distributed environment. With native support for bring your own algorithms and frameworks, SageMaker offers flexible distributed training options that adapt to your specific workflow. You can also deploy a model into a secure and scalable environment by launching it with a few clicks from SageMaker Studio or the SageMaker console. Assuming you use the SageMaker Cloud, in this video, we will talk about one of our use cases for leveraging SageMaker. I will introduce this part in two sections, data prep and workflow. First is our data source. In this demo, the data is from a Kaggle research prediction computation called IEEE-CIS fraud detection, hosted by the IEEE Computation Intelligence Society and a payment service company, Vesta Corporation. In this competition, people will benchmark machine learning models on a challenging large-scale data set. The data comes from Vesta's real-world e-commerce transactions and contains a wide range of features from device type to product features. If successful, they will improve the efficiency of fraudulent transaction alerts for millions of people worldwide, helping hundreds of thousands of businesses reduce their fraud loss and increase their revenue. The sample data is broken into two files, identity and transaction, which can be joined by transaction ID. But not all transactions have corresponding identity information. Since the data has already been processed, we will choose some of the category features of the training set to show the distribution briefly. Card file is one of the card info features that contains the types of cards, and device type is a feature that recorded the type of device that generated the transaction. Then I will show you our workflow for the whole project. Our code consists of 5 parts: pre-processing data, training model, deploying the model to SageMaker endpoints, evaluate the model performance by invoking endpoints, and finally, clean up the resources. Next, I will demo the steps of how we implement our workflow with SageMaker notebook instance. Let's assume the notebook instance has been created and all setup was done. We can skip directly to the code section. First of all, let's begin with some imports that will be useful throughout the notebook and set up some objects, variables, and functions we will need. Then we load raw data from the S3 bucket. After this loading, we did some pre-processing that contains cleaning, removing outliers, feature engineering, and transformation. In the cleaning section, we dealt with uncommon features to facilitate subsequent pre-processing steps. Remove identifiers as they are not meant for training. Removed features with more than 19% missing values. And fill the missing values in the remaining features with 0. We then treated values in the transaction amount feature that deviated from the mean by more than 3 standard deviations as outliers and removed the entire row of data. In the feature engineering section, we split the training data into the training side, validation side, and the test side first. Then generated new features such as year, month, day, hour, minute, and second based on date time features. We also bind some features that have lots of unique values. One hot encoded all category features. And selected features based on the correlation matrix. Finally, we did some transformations on our data, such as numerical transformation and scaling. When we finish the pre-processing, we can start training our model with the data. But first, we need to upload the pre-processed data to the S3 bucket, which can be read by the estimator when it fits the model. The estimator is an encapsulate training on SageMaker with the encapsulate built machine learning model. And the model we use here is an XGBoost model supported by AWS as a built-in algorithm. Unlike the custom model, AWS built-in algorithm encapsulates many methods that can make subsequent development more convenient and simple. For example, the hyperparameter tuning. In SageMaker, you can start the tuning with a few configurations, such as initializing the hyperparameter, setting validation metrics, and hyperparameter strings. And then you can start the model training through the hyperparameter tuning job. No need to write pipelines or functions for the model selection class in sklearn, such as grid/CV or randomize/CV, and no need to import and learn about the external hyperparameters optimized libraries. In addition, the deployment of our model is very easy as well. We can just call the deploy function, and it will help us generate the model, endpoints, and endpoint configuration. If you want to use a custom model, you have to build a Docker image and encapsulate the pre-processing, training, and predicting scripts, and then upload them to Amazon ECR, then train and deploy in the same way as built-in algorithm. After deployment, the model has already been hosted in an EC2 endpoint. We can call the encapsulate predictor function in a notebook, or invoke the endpoint through Amazon Lambda to predict the fraud probability of any processed input data. Also, you can generate some plots to see the results of the performance of the model. I will show you our model results after this demo as well. Finally, we can call the delete function or delete the endpoint in the SageMaker console if we don't need this endpoint anymore, so that it won't generate further charges. Here we can see the output of our model, which, as we mentioned earlier, predicts the probability of whether the incoming transaction data is fraudulent or not. At the same time, we also uploaded the results to Kaggle for scoring. It can be seen that after some simple processing and training, the model score is not inferior to other models in the competition. What's more, you can add your own customer pre-processing methods and try other models for better results and performance, and get a model that better suits your own use case. That's all I want to share today. Thanks for watching. If you have any questions about any steps in the video or are interested in the SageMaker, please feel free to contact support@ascendingdc.com or comment below. I'll see you in the next video.
Thank you very much, Kevin. See you later. Bye.
Please leave your comments, questions, critiques to us so we know you are watching. Again, please like, share, and subscribe to our channel, Ascending DC, and stay tuned for our next video. See you next week.